Welcome back. So in our last section, we started talking about limits and we looked at the graphical approach of limits. Today what I want to look at is the numerical approach to limits. So we're going to look at the numbers around those certain values. So here in number 17, which is this worksheet's off of what we started with yesterday on the graphical approach, we're looking at the limit as x approaches 1 of x plus 3. Well, hopefully, intuitively, in your mind, you're saying, well, I know what x plus 3 looks like. It's just a linear function. We started at 3. We went up 1 over 1. There's the function. If I take x equals 1, and I look at that value, I should be able to find that value as being 4. But hold off, if you would, just a little bit on all those assumptions, because we're going to see later on where things don't necessarily work out nice and clean for us. So let's look at a table of values. And we did table of values way back in Algebra 1, so hopefully everybody can do that. So here I'm going to tell you that x equals 9/10. I'm going to ask you to find f of x. Well, again, our f of x function here was that x plus 3. That's what we're taking the limit of. So if I look at f of x as x plus 3 and our x value is 9/10, I plug in 9/10 in for x, I end up with a value of 3.9 or 3 and 9/10. As x grows to 99 hundredths, and I plug in my x value for 99 hundredths, I get 3 and 99 hundredths, so 3.99. 999 thousandths, plugging in that, I end up with 3.999. I'm going to jump over 1 for just now, just for a minute. If I plug in 1 and 1 thousandths in for x, I end up with 3 and 1 thousandths. 1 and a hundredth, I get 3 and a hundredth, and then 3 and a tenth. So as I look, sorry, these should be 4s, shouldn't they? I can't add the day, I guess. So we should have 4.001, 4, and then 4. My mistake. I apologize. So now as I look at the left side, think of as I was doing on the graph. So as I look at the left side of the graph and the right side of the graph, now I'm looking at the left side of the numbers and the right side of the numbers. So as I get closer and closer and closer to x equals 1, on the left side, what happens with these numbers? Well, they're getting larger and larger and larger, but it seems like they're starting to level out. And on the right side, same thing. They're getting smaller in this case, but they're starting to level out as well. And it appears as these values, we get closer and closer to 4. Now, again, if we look at that function x plus 3, when x equals 1, we know that when x equals 1, that value is 4. So hopefully, we take what we knew in this new idea of limits and this new concept, and we can put that together. So let's look at one where things don't necessarily work out for us. So now if I were to plug in some values, and we're going to do this in the calculator, and what I would suggest that you do, pulling out your calculator, we're going to use the table function. And hopefully you've used that before in your Algebra 2 class. I know we did it in pre-calculus. So we're going to go to y equals. I'm going to clear out everything that's in there. I'm going to type in that function. Remember, I'm going to put the numerator in parentheses. So I have x plus 3 in parentheses. Divided by, I'm going to put my denominator in parentheses. So 2x squared plus the 5x minus the 3. Since I have different x values I want to plug in, I'm going to change my setup. So I'm going to do second window. And I'm going to come down here to the independent, and I'm going to make sure that I'm on ask. You should be, since we've been working on this in class, but if you're not, go ahead and put it on ask. Then we're going to go and quit out of that. And then we're going to go into the table. So second graph, or the table. And now what we can do is we can type in these x values, and it will spit out my y value for me. So I'm going to type in negative 3 and 1/10. And it's going to give me a negative 0.1389. I type in negative 3 and 1/100th. And I get a negative 0.1425. If I plug in a negative 3.001, I get a negative 0.1428. Now by plugging in negative 3, I get an error. So now the limit is not going to be the actual value of the function, because we know, since we had an error there, this function is not defined at negative 3. So we've got to use the values on the left and the right side to be able to determine what's happening to these two branches. Are they coming together to one point, or are they coming together at two different points in which the limit wouldn't exist either? Remember, up here, our two branches came together at that y value of 4, so it's easy to see. So let's go ahead and continue on down our table. So negative 2 and 999 thousandths gives us a negative 1.429. So here we had a negative 1.428. Here we're at negative 1.429. At negative 2.2 and 99 hundredths, we get a negative 0.1433. And then at negative 2 and 9 tenths, negative 1471. Again, if you want, you come over here to the y values, and it'll actually give you the string of numbers. So we see that we actually get larger numbers there if you would like, and that may be helpful as we examine this a little farther. So if we examine this as 0.1428, this is actually a 1 here and then a 6. Here on the other side, we get the 2, this is actually an 89797. So, not that we have to be that precise, because 3 decimal places is all we really need to be able to see. But what do we notice with these values? It looks like these values are all increasing. So we're at negative 1.3, negative 1.4, negative 0.14, negative 0.14. Then here, negative 0.148, or negative 0.147. So what's happening here around 3? Well, from the left side, it's increasing. From the right side, it's decreasing here. So it would appear that this is approximately negative 1.428, maybe 7, maybe 8, 7.5-ish, somewhere in between these two numbers. So again, we're looking at 3 decimal places accuracy, so I can say pretty certain that the limit of this function is going to be negative 1.43 as we get closer and closer to that x equals 3 mark. And again, we'll look at being able to find this exact as we get later on into our algebraic and our analytic sections. So in 19, we're looking at x going to 0 of the cosine of x minus 1 over x. So now we get into a little bit of trig. We love trig, don't we? First thing we got to do is make sure that our mode is in our correct mode. In calculus, we're always going to be working in radians, never work in degrees. So I want to make sure, again, if we hit mode, which is next to the second button there, we're going to make sure it's in radians. If it's not highlighted, make sure you go ahead and highlight it. I'm going to go to y equals. I'm going to go to the cosine of x minus 1. This is my numerator. So the cosine of x. Parentheses get a little cumbersome here. So I have cosine of x. I have to end my parenthesis. Minus the 1. I'm going to end my numerator's parenthesis. Divided by that single x. Now I'm going to go ahead and do my table. And again, we can type in these values. So I get negative 1/10. So I've got 0.04996. Again, we can go out 3 decimal places if we want. Doesn't really matter at this point. Negative 1/100th. So we get a 0.005. Negative 1,000ths. We got, oh, that's interesting. We have 5e negative 4. Hopefully, remember that that e means exponential, so we have 5 times 10 to the negative 4th. So that means we're going to have 4 zeros and then a 5 after it. So we're getting pretty close, pretty small numbers there. We should say that these numbers are getting very, very close, very, very, very small. If I plug in 0, there's that error again. So again, remember, the value doesn't exist, but does the limit exist? Do these values get closer to each other? And we're not going to tell that until we look over here on the right side. So if I type in 1,000ths, looks like we get a negative, we get a 0.665. No, we don't. Sorry, I read the wrong number there. We get a negative 5 e to the negative times 10 to the negative fourth. So again, that's a negative point. We have 4 zeros in a 5. So again, a very small number. If I type in 100th, I'll read the right one this time. We get negative 0.005. And again, last one, 1/10 gives us negative 0.05. So now if I look at these numbers, here we got very, very small. Here they were negative values, but again, they're getting smaller and smaller and smaller. So we should see that these are getting closer and closer and closer to the value of 0. So the limit as x goes to 0 of the cosine of x minus 1 over x gives us 0. And we'll talk about this one a little more as we get into, again, to the analytical part of it. But hopefully that table makes sense to us. The last thing I want to talk about today is a couple of special limits and an oscillating limit. So if we take the special limit, the limit as x goes to 1 of the absolute value of x minus 1 over x minus 1. So here what I would like to do is to go ahead and put that into the calculator and look at the graph of this. So if I take the absolute value, to get the absolute value I can do math, go over to num, it's number 1. So give me the absolute value of x minus 1. And I'm going to divide that by my denominator of x minus 1. Again, make sure you put your denominator in parentheses. Numerator is in absolute values, which acts like a parenthesis in this case, so we don't have to worry about putting that in parentheses. Now if I graph this, notice what happens. We get this interesting graph that comes over like this, and then up here goes out like that. So if I look at the branches of this, the limit as x goes to 1 actually does not exist. And this is a very important graph, especially as we get into derivatives. So you'll be wanting to look at that. As I look at x equals 1, remember if I plug in 1, I get 1 minus 1, which is 0, over 1 minus 0, which is 0. So I end up with a 0 over 0, which is undefined. So the value doesn't exist, and the limit doesn't exist. Well, if I look at the limit as x, the absolute value of x minus 2 over x minus 2. Again, I can go to y equals, I can plug in that absolute value of x minus 2 over x minus 2. Graphing it, we should see, again, we get the same kind of graph, but now it's moved over to 2. So again, that does not exist. Finally, I want to look at the limit as x goes to 0 of the sine of 1 over x. So going into y, we have the sine of 1 divided by x. If I look at the graph of that, isn't that interesting? So it looks like we have horizontal asymptotes, which we'll talk about much later on. But what happens as x gets closer to 0? Now if I take my window and I change those x values so it's a very small, so maybe if I go from -1 to 1, maybe then it'll make a little more sense to me as I look at the graph. So again, here's the graph. And again, it's kind of goes haywire there around 0, doesn't it? So if I change my window again, maybe, well, what happens if I'm at -1/2 and a 1/2? So as I look at this graph, and then it just kind of goes crazy as well, doesn't it? So what's happening there? Well, if we do a table there, what's happening around 0? Well, if I look at my values, on the left side, I go from like almost a half, kind of a little less than half. Then I jump down to a negative. At 0 again, I have an error, because that's what we're looking for the limit of. But here at a thousandth and a hundredth and a tenth, we have negatives, but then it jumps up to being a positive. Well, what happens if maybe we were to plug in a number that's even closer to 0? Well, notice we get a negative number there. Well, what happens if we plug in a number that's even closer to 0? And notice now it seems to be getting a little bigger. So this one actually, it oscillates. It goes up and down and back and forth across the positive and negatives. So in this case, we call this an oscillating limit. And in this case, the limit is not going to exist either. And again, we'll talk a little bit more about those as we get into the analytic and the algebraic form of them. And that's our numeric approach to limits.